All right, welcome back everyone. We got 3.1 pointers, the infamous pointer lesson. Pointers can be pretty confusing at first. I know that the first time I saw pointers, it was very difficult for me to wrap my mind around it. It's one of those things that practice makes perfect, and the more you use them, the clearer they will get, okay? So if you're super confused at first, keep trying, okay? All right, let's talk about what we're going to go over. We got a couple things. We're going to talk about why we need pointers, what is a reference / pointer, and how to make and use them. And of course, with a live example. Now, I know reference is a new example, something very similar to a pointer with little differences, and that kind of also adds to the confusion, but hopefully I can break that down for you guys. We're going to talk about complicated C++. So I like these little additions because C++ is considered very complicated, as many people probably know if you're watching this video. And, there's certain things they do that don't help that complication, right? And that's what that section is always about in all the videos, is kind of breaking down what makes that complicated. So you're going to see the star and the and symbol are used for a lot of different things, okay? And so I'm going to break down when you use it a certain way, it means a certain thing. Pointer pitfalls, okay? This is an important one. I'm going to show you guys kind of where, what are the biggest mistakes people make when they use pointers. And then we're going to start getting into heap and stack. Okay, so simple dynamic memory with the heap and stack with pointers. And this is really, to me, the true usage of pointers, is that we can start making things on the heap. Okay, I'm going to talk about all the type of pointers, well, most of them that there are. And then, of course, you'll have a quick code so that you can practice this with a live example of what that should look like. Okay? All right. So why do we need pointers? Let's break this down. So, we got some right here. So roundabout ways to update a variable from a different function. This is a super basic example of the start of needing pointers. It is not the only reason. It's our first reason. And if you look at this code over here, in our main method, we created a variable for age, but we wanted to write another method to change that variable, which is probably what you would do if you have a bunch of variables. You're going to write methods to change them, right? Maybe this would, in a real program, ask the user, sorry, I got your age wrong. Like, what do you want me to change it to? And then I might need that variable again, but the problem is when you call it here to change the variable and it's a void method, this is a different variable. Right, we have to remember that scope of functions. This int age is different than this int age because this is a parameter. So this essentially does nothing. It takes 30, it sends it here, it says, age is now 20, but in our main method, age is still 30. Okay, if you actually want to change it, you would have to do the second option. You would have to create a function that returns the new value. Okay. So here we send 30, right? Which, of course, the way this is written, it didn't really matter, right, to send anything. We said age is now 20, and we return it. And then when we return it, we have to resave it, okay? Starting to seem very complicated. So pointers are first going to help out with this, okay? Now, let's break down these three new types of variables. Let's break down three types of variables. Two of them are new. This first one, a variable, is what you've been doing up to this point in all these videos, okay? It stores a typed value and allows you to access it by name. Int name equals 12, right? Semicolon. You've seen a ton of these variables, okay? A reference is a location where that typed value is stored. And what we mean by that is in memory, okay? These things have to be stored somewhere. And when you want to change their value, you need to know their location. When you make these standard types of variables, all of that is done for you, okay? When you start to make a reference variable that stores the location of a variable, you can start passing around that memory, okay? Now, a pointer is a variable that stores a reference. So let's kind of break this down again. A reference is the location. A pointer is a variable that stores that location, okay? It's as simple as I can make it. All right, so we kind of need references in order to make pointers, okay? And again, we're talking about basic pointers here. There's some really complicated pointer stuff out there, all right? All right, let's look at what this actually looks like. Here's a variable, int age equals 30. Very, very simple there. Okay, they could be declared and initialized separately. We could do lots of stuff with this. We've been working with those for a while. Okay, let's break down what a reference is. So a reference, in order to make a reference variable, and this is where things are going to get confused. You've already heard me refer to this two different ways. There's making a reference variable, like this, and then there's using a reference to create a pointer. Okay, and again, I know, complicated. We're going to break this down. Okay, and truth be told, I use references more just to make pointers like this. I don't necessarily use them a lot like this, but they have their place. Now, when you make a reference, it has to be initialized, which means immediately you have to give it a variable. Okay, they can never be null, and they cannot change the reference they're associated with. So once you make a reference variable to something, it cannot change, which you're probably kind of noticing there's some rigidness to the reference variable. It can't change, right? I like my things to be able to change, all right? Now they act as what's called an alias to a variable, which means that now, let's say I created this variable and then I created a reference to that same variable age. Now I have two ways of referring to the same variable, okay? Now to make a reference variable, we put the ampersand, which is the and symbol, in front of the variable right here. Okay, that's the only difference. Now that is called, that ampersand symbol, we don't call it the ampersand, we call it the address of operator because it gives us the address of a variable, okay? Now its location can be in separate places, all right? Notice how here I put it right in front of the variable. That's the style that I like, okay? I like to put it in front of the variable name. However, if you look down here, it could be next to the data type. There could be a space in between them, or it could be next to the variable like I did. All three of those are the same, okay? Now let's break down a pointer. And this is really going to be the focus of this lesson, is using a reference to a variable to make a pointer. Pointers can be declared and initialized at different times, okay? Which means I can just write this first part and then later give it a value, okay? Pointers can be null, and null is a special little value that means nothing. And pointers can change what they point to, which means I can give it a new value whenever I want to. Now to make a pointer, we use the star symbol, and the star symbol is called the dereference symbol, okay? And we're going to break down why that means that it's called the dereference symbol, okay? And its location can also be in separate places. You could see that it's next to the data type, it's in the center, or it's next to the variable. I like putting it next to the variable. You choose how you like it, okay? All right, let's see where we're at here. Okay, complicated C++ addition. Let's talk about why what you're already seeing is ridiculously complicated, okay? The and symbol means different things based off where it is. Same thing with excuse me, I should call it the right way. The address of operator and the dereference operator mean different things in different places. So let's look at the reference. When we use it here in the front next to the variable, we're creating a reference variable, an alias variable to another variable, okay? When we put it here, we're grabbing the address of that variable and storing it into a pointer. Very, very different thing, okay? Now, other usages of the and symbol is a bitwise operator, which I know we don't know what that is. And when you put two of them next to each other, it's the and operator. So we see it used at different times in different places. And that's where C++ gets complicated. We have one symbol that based off where it is will mean different things, okay? Now let's look at the pointer. The star symbol means different things based off where it is. So when it's in the front here on the left side, when we're making a variable, you're telling the compiler, I want a pointer variable, a variable that points to the memory of something else. But when it's used in an expression, like over here, where it's, an expression is, a statement of code, it gives me access to the value of that variable, hence the name dereference, okay? So think about it. If the reference means the memory, then to dereference it means instead of looking at the memory, I want to look at the value. So we can use pointers in a really cool way. We can use just their name to print out the reference, or we can dereference it and get actual access to the value. And again, I know it's complicated. It'll be a lot easier when we see an example. And then, of course, there's other usages for this symbol, right? We can use them also for multiplication. So a third one. So you're going to see sometimes they're using an expression to say that they're multiplying. And so here's kind of the key thing here. This previous example, I said that they could be in many different places when you create a variable, right? Well, when you're using it in an expression, it cannot be in different places. It has to be right next to it. And that's why I keep mine right next to it here. I like to just practice that because it can mean something else if it's not right next to it. Okay? All right. That was a lot. And you're probably kind of confused right now. That's all right. Let's do an example. Let's clear the air on these pointers, show you that they're not as hard as they seem. Okay. So we're going to do an example, and there's going to be a couple things we're going to do in here. We're going to create a basic pointer, observe its output. We're also going to pass it as an argument, and we're going to look a little bit at references. Not too much at references, but a little bit. Okay? So first thing first, to make a pointer, you need a variable. Okay? So I need to have a variable. I'm going to make int age. We're going to use a lot of the code that we have. I'm turning 30 soon. Please help me. Okay? And, everything's very simple at this point. Let's just print out age. Let's add some code here, or some text here. So my age is age. Nothing's crazy here. Okay. Let's compile that. Oh, give it a run. And you can see my age is 30. Okay. You just created a variable, a very standard primitive variable. Okay. Now, let's look at the reference, okay? Let's just print out the reference of this variable. So I'm going to go cout, and I'm going to say my age is stored here in memory, okay? And I'm going to use the address of operator, so the ampersand. I'm going to go age, like this, okay? Let's watch what happens. So we give it a new compile here, and a run, and look at this. My age is 30, my age is stored here in memory, this location. Okay, so, memory is stored kind of like a grid, all right? And so this is the grid location. So if you're playing Battleship, you're like, oh, is your battleship on C3? That's a location on a grid, right? We just have many more grid squares, so we need a much larger hexadecimal number, okay? Now, if you have this memory, you can pass it to other places, okay? And if you can pass it to other places, you can manipulate it whenever you need to, okay? I know that was complicated, but let's see what an actual pointer is now. Okay, a pointer is really just what's supposed to store this memory. So int age is equal to 30, age stored 30. Now we want a variable that just stores this memory place, okay? Now the way we do that is I go up here, I'm gonna go int, and I'm gonna use my dereference, although it's not really dereferencing there, right? And I'm gonna give it a new name. And this is generally the standard that I use. If I'm pointing to a specific variable, I put PTR at the end so that I know that this pointer is supposed to go to age. Now, if your pointer is going to change and point to many different things that are unrelated to each other, you'll need a different name, okay? And now I'm going to use the address of, so right? Age, okay? So let's break that down. This is a pointer, all right? It is a specific pointer variable that will store a pointer to an integer, okay? Now notice how we didn't say this was equal to 30 or anything like that. You don't do that with pointers, okay? You don't sit there and create a pointer and give it a value. It needs to point to something, something that already has a value, kind of, okay? So we set and like, hey, let's pull the address of age and do that, okay? So now let's break this down. Let's go and let's see what this looks like. So cout. Right, I'm going to say my, let's go my age pointer is, okay, and let's observe what happens when I just use the name without the star. So I go age pointer, and let's observe what that value looks like, okay? So compile, run, and notice the same place in memory, okay? At the surface here, that's all we've had to do, right? We're just storing the address of that variable. So that pointer points to an address. Okay. Now, what's cool with the pointer is I can also get the actual value. So I can go my age from the pointer is, and I go and use the dereference operator, which is again the star. Hopefully your brain's not melting right now, right? Let's give it a compile, give it a run, and we're back to having 30, okay? So there's a lot going on here, right? And this is where it gets complicated. This star symbol used here in an expression meant to dereference it. So don't give me the address, give me the value. When you print out the pointer just by the pointer's name without the star, it gives you the address. When you print out a variable and use the address of operator, you get the address. And of course, when you just print out a variable by its name, you get its value. So you may be going, what the heck? Up here, I was able to do this. I was able to get the value and the address without having to have a pointer. And it seems like you just introduced to me the same exact thing, but with a pointer. Okay, so let's observe why this is important. Let's create a method. Let's call it update. And it's going to be a void method. So void update, and it's going to take a pointer. So it's going to take, points, right? Which is a pointer, all right, to 2 points, okay? And then I'm going to sit there and give it a value that I want to update it by. We'll just call it PTS for points again, okay? So this method will take a pointer. So notice that if I want to take a pointer, I have to put the star here, okay? And it's going to take a value to update that by. So let's go define that, okay? Or let's go do, we declared it. Let's go define it. So void update int star points int points, okay? And now I'm going to say star points, which is the dereference. Okay, so I'm saying give me the value of the pointer, okay? And I'm going to say plus equals 10. So this should, okay. I'm using age here for this example, but just so you know, I'm using a point example for this method. I'm going to kind of clean up this main in a second. Sorry if that's confusing, okay? So I'm going to update the points by 10. Notice how I'm not going to return anything, okay? All right, so let's go int, and we're going to make just the regular variable points is equal to 100. The user has 100 points. And I hope you're getting the clue here that you need a variable first before you get a pointer. And then I'm going to go int points pointer is equal to the address of the pointer variable, okay? And then I'm going to call update, which takes a pointer, so that's my points pointer, and a value to update it by. I'm sorry, I made a mistake here. Not plus equals 10, plus equals points, okay? And let's update it by 25 points, okay? Now, in main, look where I'm doing this. In main, I'm going to say cout points, which was the original variable here that we created at 100, which, think about this. According to everything we've known about functions, this has no scope over this function has a different scope than the other function, right? So let's compile, and let's run this. If this was a regular example, that should have printed out 100, right? Because they don't have the same scope. I made an error. Initialize an argument. What have I done? What have I done? So, okay. All right. I believe that's my error. So let me break this down again. So, nope. What have I done? Oh, okay. So silly. Literally, look at me. I hope you guys noticed that. I didn't even make a real pointer. Okay. Whew. Winter break. Winter break. And then, of course, I need to drop that off. Okay. Got a lot going on here, everyone. I'm going to explain all, okay? Boom. compiles successfully. We run it, we get a 125. So let's break this down again. All right, I'm gonna use my comments, okay? We created a variable, very simple, right? We created a pointer to that variable. All right, now I made a mistake. I was supposed to put the star, my bad, okay? Now we sent the pointer to a different function, which normally when you do that, you get that pass by value. And here it's a pass by reference. We're sending the reference. Notice how there's no point here, or there's no star, okay? Because remember, if I put the star, that means dereference, give me the value. I don't want to send it by the value. I want to send it by the reference, okay? Its location in memory. So that's why there's no star here. There has to be a star here because you have to say I'm receiving a location to a variable, its reference, okay? And then so here it updated it by that 25. Again, I had to use the dereference here so that I get the actual value. And then look where I printed this out. That means that this function, because it knew where this variable was in memory, it could update its value. All right. Now it doesn't seem too important right now. Like that's still a lot of work according to your problem that you had at the beginning of the lesson, right? And you're right, that is a lot of work. But when we get to heap variables, it all of a sudden becomes something you can't do with regular stuff, okay? So let's get back to our lesson. Okay, so that was a lot, guys. Extremely long video so far. But let's talk about this, okay? So pointer pitfalls and errors, okay? Assigning a value. This is a big issue that you might see, okay? You go int, you make a pointer, you put the star, it's equal to 10, not what we can do here. When you put the star, okay, and creating a pointer, you have to pass a reference, not a value. Okay, so you can see invalid conversion from int, see, look at this, int variable to int star, because this is trying, this can't convert to a pointer, okay? So big error here, make sure when you make a pointer, you're setting it equal to the address of a variable, not a value, okay? And then of course I should have added a common pitfall is forgetting to put the star like I did. Another big pointer pitfall. And this is again where C++ gets very complicated. So look at this code. Int star age equals pointer 2 is equal to return pointer, okay? So we're saying that we want to get a pointer back from a function. This function is returning a pointer. This is a big no-no, okay? Even though we can now, how do I say this? Even though we can change variables from other functions now, we still have to remember that when a function ends, all of its data is deleted, okay? So for instance, this function return pointer is going to run. It creates a variable, it creates a pointer to that variable, and it returns the pointer. But when this return runs, this function ends, which means all the stuff, all the variables that it created are deleted. So you just passed back a deleted pointer, okay? It's going to create issues. Your program might still run. It might not fail compile because there is some circumstances you can return a pointer, but this is not one of them, okay? So moral of the story is, as of right now, don't return pointers, okay? All right, I know I put a live code there. I think we're pretty good. I don't think there's too much to demonstrate here except for avoid returning a pointer. Don't make this mistake, okay? Okay, all right, let's move on here. Let's talk heap versus stack, okay? So everything you've been doing has been used in stack memory so far. We're gonna start looking at ways slowly on how we do things in heap memory, okay? So let's talk about the benefit of each. Stack memory is really fast, okay? It's fast memory, right? It's operating system managed, which means your operating system will delete, create things upon your request, okay? And in fact, before I go on, you've been using stack memory without realizing. When you create a variable, it's in stack memory, okay? So when you go int age equals 30, that's a stack memory, all right? If you don't know if it's in stack or heap, it's in stack, because you will know when you create a heap variable, okay? And it's all local variables are in the stack memory, okay? The stack has a size limit, okay? And that's kind of where we get to this limitations here, is that there's only so much stack memory for a program, different for whatever operating system you're using. There's no resizing allowed, which means you can't, sit there and go, I want more space for this variable. And it's organized as a stack, which is last in, first out, which means everything is organized on top of each other, kind of how these are organized on top of each other. And it's all very tightly kept by the operating system. It'll move things around as it needs to, okay? So if you don't know which memory to pick, you just pick stack right now, okay? We're going to start looking at cases where heap memory becomes more important, okay? So let's talk about heap memory. Heap memory is slower than stack. It's programmer managed, which means that, it's not as efficient as the operating system. It means you have to do the managing. I don't know why my numbers are all off here. Your global variables are generally in the heap. There's no size limit, which means you can get more heap if you need it. Resizing is allowed. There's no organization, which means that there could be a bunch of empty space in between your stuff. And it can lead to memory leaks. And that's very important that it can lead to memory leaks because, if you don't efficiently manage the stuff that you create in heap, it'll stay alive, okay? Now, generally speaking, it could be deleted by the operating system, but that's not a guarantee, okay? Now, there's a reason why this is a cloud. There's a reason why this is a box, okay? Your stack memory is organized. Your heap memory is kind of all over the place, okay? So why use which one, okay? Well, if you think about this, it really comes down to your sizing limits, okay? And your resizing ability, all right? If you need something to be created a certain way, you need to do it in heap if you need that customization. If you don't, leave it in the stack, okay? Now, you need pointers to make something in the heap, okay? Now you must include, in order to use this malloc method, you must include the C library to use malloc and free. So this is malloc and this is free. I'm going to talk about what they mean. And that library is CSTDLIB. So C standard library, okay? What malloc does is returns a void pointer, okay? But it returns a void pointer to the amount of space that you request, okay? And after it returns that void pointer, you need to cast it to an integer. So let's look at this pointer example. So int star age, so everything on the left is correct, except for then we cast it. So we go int star, we say we want to cast this to an integer pointer. We call malloc, and we send it the size of what we want. So remember, size of operator returns the amount of space of something, and we say we want the same amount of space for an int, okay? And then we can give that a value, right? Just like by using the dereference and go, okay, so I created that and now I want to give it a 30, right? And so now you have a variable that's in the heap, okay? You just created something in the heap, all right? And the thing is though, you have to manage it. So when you're done using it or your program is ending, you need to free that memory. So you call free and you send it the pointer, okay? Without the star, all right? And it'll delete it, okay? Now, this is the C style way. There is new ways of doing this, but they kind of abstract their requesting of a specific amount of memory, which I like you guys to see. All right, I think that this really sums up very well on what's happening. But I will kind of talk about those in the future. Now, if you were already confused by pointers, and now you're looking at this, you're probably super confused, and that's okay. We're going to ease into dynamic memory and only use it as we need to for now. But know that all advanced programs are going to have dynamic memory in it, and you need pointers to do it. So if you didn't feel like pointers were worth your time before this page, you're like, oh, well, I don't really need a pointer. You didn't show me an example where I needed a pointer. This starts to become the one where you do. Malloc returns a void pointer. So if you want to start creating your own space in there, right, for things that you don't know how big they're going to be until runtime, you have to use dynamic memory. You have to use a pointer. Okay, now I'm going to do this example real quick. I'm going to do that example so you can see it in action. Okay, so in order to use your dynamic memory, you have to include, okay, up top, you have to include the C standard library. Okay, if you do not include this, you will not be able to do any of this stuff. Okay, now notice with the heap pointer, I don't need a variable already. So I can go int, and I can be like star, here's my age pointer. Okay, and then I set it equal to, and I'm not going to cast it yet, I'm just going to do the malloc part. So malloc, which this is a function that requests, see, look at this, allocate size bytes of memory, so you have to send it the size. Okay, now instead of sitting there and saying that, I want 8 bytes or something like that, instead of writing in the number, we can request the size of certain things. So it could be like size of an int. Now, if I wanted to create an array, I can say, oh, times that by 8, so that I can have more. Okay. So remember, the int is 4 bytes. So you could say, I want 8 sets of 4 bytes. Okay. Which would be 32 bytes worth of memory so that you can have an array. Okay. Now this is going to fail right here. So let me compile this so you can see that failure. And you see we get this error. Invalid conversion from void star, so a void pointer, to an integer pointer. Okay, that's all right. That's why you have to come here and cast that void pointer to an int pointer. Now, if you're creating a double, you would do a double star. If you're creating a string, you would do a string star, and so forth. Whatever you need to cast it to. Okay. Now, I can actually give this a value. I can sit there and say, and use the dereference because I want to actually work with the value here, and say that's 30. Okay, and I can print out 2 things. Okay, so location, right, which you remember for doing the location, we just pass the name of the pointer. And then we can pass value. All right, which is using the dereference like such. Now, here's the thing. At this point in time, I've created a memory leak. I've created a heap pointer that's never deleted. This can get really dangerous because if you never delete them when you're done with them, then all of a sudden you're creating a bunch of stuff that's not being deleted. Your users' computers are going to start to slow down. So the general guideline is every time you write a malloc, you write a free. So I'm going to go free age pointer. Okay. All right. Let's give this a compile. What's going on here? Age was not declared in the scope. That's because I never created this variable. I'm a little rusty here. Age pointer. These should all be age pointer. Very sorry about that. Age pointer. All right, let's give this another go around. Okay. Boom, look at this. Location, value. Now at this point, it might not seem like we've done anything different with heap and stack. I totally get that. We're easing into heap, all right, because it starts to get very complicated. So we're going to just slowly introduce things as future lessons go on, and they will be very important for our next couple lessons, which are about classes. Okay, so we're really close to wrapping this up. There are other types of pointers, right? There were, variable pointers, which is kind of what we were just doing. There are pointers that pointed to a variable. You can have an array of pointers. You can have null pointers. You can have function pointers. You can have smart pointers. You can have class pointers, okay? Which is why this lesson is covering basic stuff that doesn't always seem to show the value of pointers, is because I know how complicated pointers can be and I want to ease us into it, okay? And in fact, the hardest thing, you guys, it's just going to be, where do I put this symbol? How do I, I got to put a star here. I got to put an address symbol here. Let's just focus on creating some basic pointers, okay? Now, here's going to be your quick code. It's just playing around with the pointers a little bit. So you're going to create a simple point system using pointers that has 3 methods, okay? And the pointer that you're going to make, you need to make sure you create that pointer in the main method, all right? So you're going to have void update score, you're going to have void random update, and you're going to have void print points memory, okay? So the update score should take the pointer and the amount you want to update it, which we've basically just did that, right? The next one is random update. It should randomly add or subtract from it, okay? So it's, let me break this down. There's really 2 randomness there. Random that it adds or subtracts, So each time that one runs, it should either add or subtract. And then also then add or subtract by a random number. So you will have to generate 2 random numbers. And then you're going to have void print points memory. So you're going to send it the pointer, and it's going to go, this is where that is in memory. Okay. Now you do have an advanced opportunity to do this with heap pointers and make sure to not have any memory leaks. Okay. Notice how I'm not requiring those yet, but you will start to get to points where heap becomes very important. In my second course, where we would do 2D game programming, you cannot do game programming without pointers. You need access to the actual variables. Okay. Now, our last piece is what does this Quickcode actually look like? So let me show you a little bit of runtime here. Okay, so here is an example of what this should look like. Okay, and I didn't implement all the functionality, and already, there should have been an end-all right there, but your score is currently 10. Choose your operation. Okay, and you get the update score, the random update, or the pointer memory location. And remember, each of these needs to be its own function. Okay, and I'm only implementing random update right now. Okay, because I feel like the other ones are not too hard. So when I press 2, we get the random update, changing the number by 42, and your score is now 52. Okay, pretty straightforward, right? Let's run it again. 2, change the number by 11, your score is now 21. Run it again, let's see if we can get a negative to pop up. Change the number by negative 43, so your score is now negative 33, because 10 minus 43 would be negative 33. All right, I actually did this using only one random number that allowed negatives, okay? If you're interested in that, let me know and learning how to do that. But other than that, it shouldn't be too bad of a quick code. Should help you kind of get your feet wet. Okay. All right. That's a really long video. I hope you enjoyed it. Like and subscribe. Comment if you need help. See you later.